All right, let's get started here. Today we'll be discussing transfer efficiency and its connection to sustainability. Joining us today is research engineer Paul Vesely from Spraying System Company's Research, Spray Analysis and Research Services Group. Also joining us is regional sales specialist Justin Berger from the Gulf Coast region, and Anthony Wood, who is in our sustainability team. All right, welcome in, guys. Justin, you want to get us started?
Yeah, thanks, Mary. Thanks for joining us on this webinar regarding transfer efficiency. And, you know, when we're working with spray technology, not only is it important to understand the spray as it's traveling in, as it's traveling through the atmosphere, but it's also important to understand that whenever we're spraying, how is what we're spraying achieving and hitting our target? And so, Mary, we'll go ahead and get rolling. So what is transfer efficiency? So it's really looking at the amount of spray that leaves the nozzle versus where it ends up. So for example, we're spraying a spray can of spray paint, for example, and anytime we get over spray, taking that percentage is your transfer efficiency. So perhaps we can get 90%, maybe we get 98%, or maybe it's 50%. And understanding that that transfer efficiency ratio, it can be very important on process improvement initiatives. Next slide. So we're going to look here at how we can assess transfer efficiency and really how we can quantify it. So we have Paul here who spends quite a bit of time in our lab, and he and I have had some exciting projects that we got to work on in the past. And Paul, can you describe kind of what we're looking at from more of a qualitative standpoint on this conveyor testing and what insights you might be able to glean with regards to transfer efficiency?
Yeah, thanks, Justin. We have in our facility a laboratory conveyor system where we can simulate our customers' line speeds and conduct spray trials, various fluids, temperatures, nozzles, and operating parameters for those nozzles on substrates, and assess try to help figure out what's the best nozzle, optimal nozzle for that spray process, and the optimal spray conditions to produce that coating, that spray coating that our customers are looking for. And we can quantify the transfer efficiency from this by knowing how much fluid we're dispensing out of the nozzle, and then weighing the substrate before and after spraying, and use that to determine if we're improving or the transfer efficiency of that spray process.
Yeah, that's great, Paul. You know, one neat method that we've seen is, like you said, that weight differential. And oftentimes in food industry, that can be very important, you know, making sure that we're right in those bounds of weight to ensure that the proper amount of chemistry or whatever we're spraying, whether it be oil or egg wash or different applications. So that can be one way of measuring that transfer efficiency, is based on weight. So we weigh the object beforehand and then weigh it after, and then we can see what that increase is, and then comparing that change to how much of the liquid that we're spraying as well. And that gives you a little bit more insights, a baseline to understand what's happening in your process and where that transfer efficiency might be improved. Now, what you see on the left-hand side is laser sheet imaging. And this is another method for us to really assess our transfer efficiency. And Paul, can you describe how you would leverage the laser sheet imaging with transfer efficiency, as well as the information that you get from the conveyor testing? How would you integrate those two technologies?
Yeah, great question. So laser sheet imaging is a nice, unique tool. It gives us a non-intrusive way to diagnose a spray, to characterize its properties, whether it's spray plume shape and size, the concentration of the spray. As for example, in this picture, we can see this is a hollow cone spray. It's got a ring of fluid that it's producing, and it's not much spray in the center and definitely not much on the outside. So we can use this laser sheet imaging technology to identify drifting droplets. This instrument uses a laser that forms out into a sheet of light, and we can illuminate cross sections of the spray. And so outside of analyzing the primary plume itself, we can also look at drifting particles and quantify how much of that is drifting away from our intended target just through the propagation of the spray. Justin, you're muted.
Yep, thank you, Paul. That's a good way for us to get more of a qualitative look, perhaps. And we'll look a little bit further as well as that laser sheet imaging, how that can translate into a quantitative approach as well. Next slide, Mary. So why does transfer efficiency matter? And what was great about what Paul said is tracking that overspray. And you can see on the left-hand side, we have our PulsaJet technology, which is very unique technology that we can maintain our spray pressure, but adjust the volume through a hydraulic method and through that PWM. But you can see that the little fine droplets that are drifting and moving away iteratively, that has a huge impact on your operations. For example, let's say you're spraying oil for a mold release, and your goal is to make sure all the oil makes it to where it needs to go. If we can start quantifying these little bitty droplets that get atomized into the air, we can start thinking about how do we optimize this? Oil is not cheap. In some cases, that overspray not only causes challenges with HSE, but it can also pose a hazard to overspraying on other equipment. And so understanding how small changes can yield big effects is very, very important. And that's where that transfer efficiency can really help us out. And along with that laser sheet imaging, using a spray scan to track overspray, we can also then quantify that with our LSI. And Paul, can you describe what we're seeing on the right-hand side here with those distributions and those fun heat maps?
Yeah, so before I get into the heat maps, the data is generated by using this laser sheet and a high-speed camera and some unique software to acquire many images of that spray and averaging that and conducting some other post-processing to those images gives us the results of what here on the right side we see 3 spray patterns all lined up next to each other. Well, we can get one of those spray patterns from doing this laser sheet imaging technique, and then we can use our software to virtually overlap and optimize the spacing between nozzles because most of the spray coating processes are conducted on large conveyors on big substrates, and we need many nozzles to coat evenly across. And not only is overspray an issue with transfer efficiency, but also applying uneven coatings across the substrate could lead to wasted product and increased revenue for that process. So using this instrument in another way, we can figure out the optimal spacing between nozzles to produce that more even coating and help make that spray process, that coating process more efficient.
Yeah, Paul, you mentioned something important, of getting that even coating, which is very important. But what is also important, whenever we can visualize this collectively in our mental models as an entity, we can start seeing, okay, this is what I see in the line. This is how it translates in a quantifiable way. And my goal, of course, is to mitigate these peaks and valleys in order to get more predictability of my process. And so this is a way collectively, not only to leverage the technology, but to also be speaking the same language of what we're trying to accomplish as it relates to process controls and going a step further into that transfer efficiency. Next slide, Mary.
Yeah, before we move on, Justin and Paul, we got a quick question in here. What do these lines on the bottom represent?
Yeah, I can field that one. So represents the coefficient of variance of that coating of that coverage across that width of those spray from those 3 nozzles. So taking the 2D map, the XY map of those 3 nozzles, that spray concentration and shape and size, and bringing that down into a 1D map of, as if we were spraying onto a moving substrate. So and then assessing that coefficient of variance across what that resulting coating would be.
Yeah, so it's measuring that nice distribution to see how that spray is moving, the evenness of that spray, Paul. That was great. Thanks so much.
Yeah, and that's great too. Please keep the questions coming as you guys see any relevant information.
So a couple of applications that we can look to, and one that's familiar with quite a bit of us is painting, and that painting technology, how it's atomized, and how do we transfer the paint from, let's say, a paint gun or a spray can to the substrate in the most efficient way possible. And one of the ways to do that is to really look at the distribution, look at what we're trying to accomplish, and also trying to mitigate all the variables that we're truly looking at. And as well as the implications of harsh chemicals as well. Perhaps there's a certain drop size with a certain chemistry that we need to be cognizant of from a respiration standpoint as well. And by getting this information, understanding it, quantifying it, we can see not only that transfer efficiency, but we can also look at the HSE challenges that might be present for certain chemistries. Next slide, Mary.
Yeah, Justin, sorry, we got another question. Can you explain HSE, what that means for some of the lay people here?
Oh, sure. Yeah. So health, safety, and environmental. Great question. And so really that's one of the biggest pieces in an industrial environment. Anytime we're aerosolizing something or spraying something, transfer efficiency goes both ways. We're trying to transfer the droplets onto a target or a substrate, but that also lends itself to potential hazards of aerosolized product that might have carcinogenic effects. And that's where the HSE, the health, safety, environmental aspect of what we're looking at is really important, because if we're able to transfer from a gun to a target to a substrate, fugitive particles will make their way into the atmosphere, into the environment. And it's important to be cognizant of that, not only for the health side of things, but from a sustainability side of things as well. Yeah, that's a great question. Thanks, Mary.
Yeah, perfect. Thanks, Justin.
So this one is interesting. Lubrication, whether that be dye lube or any types of oils that we're spraying. And Paul has done some interesting work with transfer efficiency as it relates to oil. And Paul, can you describe some of the nuance and challenges based off of the rheology or the chemistry of oil versus just spraying water? What implications that might have on a process, and maybe some tactics that can be used to enhance our transfer efficiencies?
Yeah, thanks, Justin. So oils can be challenging to atomize well and to also achieve high transfer efficiency. Oils by nature have generally higher viscosity than a lot of water-based fluids, and they also have a little bit lower surface tension. So it's easy to produce some finely atomized droplets using different technologies like two-fluid nozzles. We're using compressed air as the main driver force of atomizing the oil, and finely atomized oil that's drifting around is going to coat on other surface that you're not intending to coat. And that relates to that health, safety, environmental aspect that Justin mentioned, and also wasted product. A lot of facilities are working with oils that are fairly expensive, especially when they're used in like food applications or in other automotive and such. And so there's drifting particles, and transfer efficiency is definitely very important. Oil is also atomized generally using either higher pressure with high pressure hydraulic nozzles, or using heating as well to increase the temperature of the oil. You're also generally you're going to decrease the viscosity of the oil, making it easier to atomize. But heating oils is expensive, and that can also cause its own health hazards, from potential burns and stuff like that. finding the right nozzle for that oil, for that application to get that high transfer efficiency, but producing the lowest amount of drifting fines is really crucial. And finding what's going to be the most economical. There's usually a big opportunity for cost savings when you're evaluating and trying to improve oil spray applications.
Yeah, Paul, I'm reminded we have the privilege of walking into numerous plants, and oil, whether it be dilube or any other applications, even mold release for food applications, getting it dialed in, the spray dialed in, can mean quite a bit of money in savings, but also that health and safety side. And really to be able to assess the spray as well in live fashion. We'll get to this in a little bit, but when we look at our laser sheet imaging and those applications, which is typically done in the lab, we now have that capability to assess that on the line and to be able to make on the fly adjustments as we push forward with this technology. Next slide, Mary. So food processing, we spoke a bit about it, and this is a really important piece. We also have Anthony Wood on the line. He is part of our sustainability team, but he's also head of our food division as well. And Anthony, one of the things that we see in food, right, with transfer efficiency is getting the chemistry to flow from the nozzle to the substrate. But if you notice right here, even with some very powerful technology, what do you guys notice bouncing back after that impingement on that surface? Anthony, what do you see there?
Well, yeah, even if we have powerful nozzles like you see here, we can have a high level of transfer efficiency as far as getting the chemistry or the ingredient, the oil to the surface. But if we have too much, you can get bounce back, and then it's not staying on the substrate that we want it to stay on. And even if we get it there initially and it's not atomizing or drifting away, even in splashback, as you see in some of these pictures here, means it's not staying where it needs to stay. And if it's not staying where it needs to stay, then it's additional waste, health and safety concern, reduction in sustainability.
And even from a run and maintain standpoint as well, any of that bounce back that we could potentially get more control over, whether it be with larger size droplets, differentiation of the pressure, perhaps changing the rheology a little bit. But whenever this bounce back occurs, there's huge opportunity for mitigation. I mean, imagine, let's say that's 10% on one nozzle that's bouncing back and going other places. That's opportunity for 10% savings, not only on your pump, but also on maintenance and cleaning, as well as your chemistry and electricity costs as well. Yeah, thanks for that, Anthony. Next slide, Mary. So there are a few tools that are at your disposal to maximize transfer efficiency. One of which you guys have seen a little bit, is our PulsaJet nozzles. And what's fascinating with that, particularly in the food industry, is the ability to maintain pressure, but also adjust flow through PWM, or pulse width modulation. And Anthony, very, very briefly, can you explain what's behind that technology on the PulsaJets and what advantages the clients might see from it?
Right. So the PulsaJet line, an electrically actuated valve that is controlling opening and closing very rapidly that nozzles. But we can control based on the width of a pan that comes through, or the amount of volume that we want to provide, amount of width we want to hit, and change how fast we open and close that valve, how much time that valve stays open versus closed, to maintain the right target width that we're trying to hit. In traditional hydraulic nozzles that we wouldn't electrically actuate like this, if you reduce your pressure and your flow, you're going to get different widths of the spray. So we can still control that width and adjust flow rate through the speed of actuation.
And Anthony, I love the fact too, you know, let's say the line speeds up or slows down, we have recourse of adjusting the amount of chemistry that we're spraying based off of that electric actuation from, you know, basically a low percentage all the way up to 100% being a traditional hydraulic spray. Another piece that we get to look at is electrostatics. And Paul, I understand you did some interesting work on electrostatic technology. Kind of lets you describe what kind of pivots our clients can look at as far as getting that transfer efficiency optimized.
Yeah, thanks, Justin. Electrostatic atomization works really well with fluids that are generally pretty electrically, very electrically insulating. So it's fluids that do not like to be charged, that don't like to receive electricity to do anything functional. So they'll think of like oils, for example. Food grade oils is a good example, or lubrication oils. So this picture here we're showing is of we call it a single point nozzle, or like a chain oiler nozzle, and it's used really extensively for lubricating the links, individual links on a chain as they pass by. So this nozzle is applying an electric potential to the oil. It's generating, it looks like a solid stream of oil coming out of that nozzle, but that's just to the naked eye. It's a really finely atomized chain or stream of oil coming out of that nozzle, finely atomized droplets, and they are collecting onto the chain that's running directly underneath it, usually about an inch or so, a couple inches below that nozzle. And it's targeting the lubrication, that expensive lubrication oil right there on where the links come together. So it's a very targeted application. Those droplets have electric charge to them that they don't want, so when they're attracted to the chain, so they can relax that charge out of the droplets and get to a lower electrical potential, a lower energy level.
Yeah, Paul, what I love about this technology, whenever you get to see it in the wild or in the field, you can actually watch the spray move to the high level links, and it's actually coating that link just the right amount to where you're not getting that overspray that historically has just been based off of just a hydraulic atomization that's not on the electrostatic regime. So very, very fascinating technology. The next piece that we have to help with that transfer efficiency, Anthony alluded a bit to the PulsaJet nozzles, and those pair very well with our control panels, which are able to then control these smart nozzles, if you will. And what's fascinating with this is we're starting to democratize the data, meaning you're able to get more insights and more detail of your operation and how it's running through our technology. And the reason that's valuable is the more detailed and the smaller you go, the bigger things get. And as we get to understand and get more control over these nuances, we see opportunities for savings and for greater sustainability, and also get to start understanding a common language as well by being able to visualize what's happening with your spray and getting a little bit more detail as to what we can accomplish. And then the last piece is regular maintenance. One thing that is fascinating about nozzles is no matter the metal, the hardness, all of that fun stuff, as soon as pressure is applied to a nozzle, something will change. And granted, it could take numerous years, or depending on the abrasiveness of the liquid, it might just run for a couple of months or even shorter than that. Short story, we had clients that we were using, they were replacing a nozzle, and we received a drawing back from what's 1984, and highly sensitive process. And this nozzle has been put through the paces this whole time at relatively good amount of pressure as well, spraying some expensive chemistry. And they are just now getting around to replacing it, which has the opportunity for millions of dollars of savings as well. So it's important to understand that nozzles, while may seem a bit a smaller picture, they have implications of your upstream and your downstream processes. And this is what we're bringing of value, is the ability to get more resolution of how your plant's running, how your systems are operating, and what we can do to give you deeper insights to that. Next slide, Mary. So we spoke a bit about deterioration. Getting optics on when to replace a nozzle visually, and Anthony, you can speak to this as well. Visually, the human eye might not see any difference between a healthy spray and an unhealthy spray till it's about 30% or so over capacity. And Anthony, can you kind of speak to the implications of that from a one nozzle perspective and then to a whole process perspective?
Sure. This we mentioned earlier, Mary did at least, that our internal group here, we have some like-minded people focused on the sustainability initiatives that we can help with. Our organization's been selling sustainability forever, but more recently, we really tried to comprehensively look at the bigger picture with inside of our customers' facilities. And when you look at the vast number of nozzles in a production environment, you get 5–10% wear life that you can't visibly see, nozzles running all day in some cases, or at least first 2 shifts. You start looking at millions of gallons of either water or product that's being sprayed over what the intent is. Those millions of gallons obviously have some high dollars to them. So you do the best selection up front, you do the due diligence to select the right product, and it works great in the pilot stage. Once it's installed, that the story doesn't end there. And as that nozzle wears, your flow rates are going to continue to increase, and the value and cost of the organization is going to continue to increase as well.
Yeah, and it's finding, where the economics intersect, right? As far as replacing that nozzle, between not only just looking at what's going through the flow rate, but again, your QA, QC, your quality control issues, if you're 5% over, 2% over even. I've seen instances in different applications where a 1% overage of wear could mean a lot of downtime and a lot of challenges in their process, and may not have awareness of where that might be emanating from. So absolutely. And then of course the sustainability piece, moving liquid through an orifice requires energy, a tremendous amount of energy, and then iterate that over numerous nozzles and headers. There's a fascinating amount of opportunity there to streamline processes. Next slide, Mary. So what you're looking at here is how could we possibly quantify and detect this? You can see the worn spray pattern visually, and then we're also able to quantify that in a very easy way. You can notice in the left-hand corner that correlation coefficient is 0.67, and we can boil all of this data down in real time to say healthy spray or not a healthy spray. And instead of just looking at pressures and flows, we can actually start gleaning a more quantitative approach of how and when we need to be replacing these nozzles. And what we love about having this ability is, again, not only can you see this in real time, but it's also a great communication tool of the importance for your maintenance staff to understand why we need to be looking at our spray nozzles, because oftentimes, depending where your monitors are, pressures and flows might not pick up on some of the nuance that we see here. And at this point, you can see we can overlap the distributions, and you can see how homogeneous that distribution is for the one on the left. The one on the right, we have a little bit of peaks and valleys. And Paul, can you describe, the qualitative piece that you see in the lab? So we have these numbers and what that means, but what else do you observe in the lab when you have a worn nozzle, and what that can mean in a very sensitive process?
Yeah, so a worn nozzle is going to produce more flow at the same pressure as a new or a nozzle that's still within its design tolerances. And that's going to affect more than just flow rate. It's also going to affect the drop size of the spray. Sometimes drop size is important to a process, whether it's for evaporation or chemical reactions, or for some other various reasons. And then also it's going to change the spray angle of the nozzle, which is generally pretty critical for flat fan nozzles or spray nozzles that are used for spray coating applications. So those factors will be impacted as the nozzle wears. And generally, a worn nozzle is going to start having a narrower spray flat fan angle. So your spray pattern is going to get tighter, narrower, and heavier. You might start getting some streaks at the corners of the spray, like you see on the right image there in the spray comparison tool. You got the red peak on the left side there, and that's a good indicator that the spray nozzle is starting to wear out.
Yeah, thanks, Paul. Visually, it would be very difficult without these optics to really assess that in real time and to see it. Whereas now, this can be back into your hands to really be able to own the data that's coming out as it relates to your spray system. Great, thanks, Mary. Next slide. So what we are looking at is from a transfer efficiency, also from a sustainability aspect, is understanding where we need to maintain and what points do we need to start maintaining the nozzle. One is very simple, is cleaning, making sure that you're using something that's softer than the material of the nozzle. So various types of soft bristle brushes, those kinds of things can easily ensure that if you get some buildup on the outside, that you're still maintaining a good spray pattern, get a little bit more life out of your nozzle. And then two is the implementation side of things, is develop that schedule. And that's where Anthony and the sustainability team can really provide deep guidance and insights on treating the nozzle as you would your other manufacturing equipment, because historically the nozzle will impact up and downstream processes. If you're flowing a little bit more pressure, more electricity, more effluent if you're recirculating your water as well. And so all of those have iterative effects. And so really treating that on a preventative maintenance schedule and not neglecting that piece of it is very important. Next slide, Mary. So going back to the why does tracking, quantifying, and maximizing that transfer efficiency mean for sustainable business operations? And Anthony, I'll let you dive into that on what you've seen and what you and your team are working to achieve.
Sure, it's kind of on a couple different points here. Looking at the current state of your spray applications within your operation to understand what your current transfer efficiency is. Obviously, you guys are experts at making your product, so you found a way to make a high quality product. If we can understand where we currently are from a transfer efficiency standpoint, then we can look at both improving to increase efficiency, but then in turn, if we're increasing efficiency, we can reduce the amount that needs to be sprayed. You're getting 80% transfer efficiency now, and we can raise that up to a 95%, let's say. Less needs to be sprayed to get it where it needs to go. So when we look at that from the standpoint of what's good for an organization, a sustainability standpoint, obviously you're using less energy, you're using less product, there's less to clean, there's less to maintain, there's less that wears out over time from the equipment and the nozzle efficiency side. Which in turn both helps you sustainably as well as economically. So the ability to look at all the applications from a spray standpoint, we'd be able to help with understanding the current setup and all those areas that we can potentially improve.
Yeah, thanks, Anthony. Next slide, Mary. So kind of some next steps is we would love for you guys to register for our next talk. You can hit this QR code. Mary will also send out an email to you guys to keep you in the loop with the latest technology and latest insights on spray. And then also feel free to visit spray.com/company/sustainability. And that's where you'll be able to interact with Anthony and his team on gaining a bit of a deeper understanding on the sustainability aspect and how we can help you from a spray application standpoint. So we appreciate your time, Anthony and Paul and Mary. Thank you so much for everything. Mary, are there any questions?
Yeah. Before we wrap up, we have one question. How can I use an LSI system in my application?
Great question, Paul. I think that one might be a good one for you.
Yeah, so we've taken a laser sheet imaging system and commercialized it into a package that takes it out of the laboratory and into our customers' facilities. And we call it the Spray Scan NPT system. And the frame here that we see here in this picture with the laser limiting the spray, that's part of the system. But the software is the really big key of this. And using this, we can analyze, iteratively, check your nozzles over, over maintenance cycles and how they're performing. Like I mentioned earlier, nozzles as they wear will output more flow, but they also will change their spray pattern and also their spray plume angle and other characteristics of that spray. So, as you do your maintenance cycles on these nozzles, you can quickly do a quick test with this laser sheet imaging technique and see how your spray compares, and you can save that result, for the new nozzle compared to, every monthly maintenance or quarterly maintenance that you do on the nozzle, and you can line up those results next to each other. And Justin showed earlier that comparison tool, which showed 63% overlap from the new versus more nozzle. That information will be very useful in determining when it's time to change that nozzle or to help develop those maintenance replacement cycles.
Yeah, I like that, Paul. And, to get a methodical way of assessing the spray instead of either visually, which may be too far out for us to even discern, let's just clean this thing and stick it back in the process, but also to prevent you from replacing a nozzle unnecessarily as well. So it's kind of a both double-edged sword that we can leverage with that technology. Yeah, that's a great question. Any other questions out there on transfer efficiency, the technology we spoke a bit about, or even general application questions? We're happy to discuss.
Nothing coming in yet so far, guys, but we can always also refer to them to the spray.analysis at spray.com inbox. If you have any questions for Justin, Anthony, or Paul, please send them there and we can answer them on your time too. Great.
Thanks, Mary.
Thanks everyone for joining. Thank you, Anthony. Thank you, Paul. Thank you, Justin. Like Justin said, we hope to see you at our next talk where we'll be discussing spray characterization 101, how sprays form and why this matters. Hope to see you there.
Thank you.
Thanks. Bye-bye.
Bye.